In this video lesson, we are going to explore some more different strategies and approaches to questions regarding permutations and combinations. So here the top question. We want to make 3-digit numbers with the digits 1, 2, 3, 4, 5. Alright. So we have part A and part B. How many 3-digit numbers can be made if you allow repeat? And what if you do not allow repeat? Okay. So first of all, if you allow repeat, right? So imagine we have 3 boxes, all right? We choose 1 digit for each box, right? Among these 5 digits. So because you allow repeat, so every digit can be reused over and over again. That means you allow digits like 3, 3, 2, or maybe 4, 4, 4. These are okay, all right? So we can have 5 choices in each box, all right? For the first box, you have the choices 1, 2, 3, 4, 5. And then so is the second box, so is the third box. So the answer goes to 5 times 5 times 5, and the answer is 125. There are 125 different 3-digit numbers you can make with the digits 1, 2, 3, 4, 5 if you allow repeat. On the other hand, if you do not allow repeat, what does that mean? Alright? That means you pick 3 digits out of the 5 and try to line them up. Alright, so the order is important because for 3-digit numbers, 2, 3, 1 is not the same as 1, 3, 2. Alright, so the ordering is important. It is a permutation question. In other words, we want to permutate 3 numbers out of 5. So the answer is 5p3. Right, we want to permutate 3 digits out of 5 digits. So the answer goes to 60 if you do not allow repeat. Alright. So as a starter, we can think about this question. Now, and then gradually we want to add more and more limitation on this one. Now, the second question at the bottom part of the screen is almost the same, only that we are limited to odd numbers, 3-digit odd numbers. How many 3-digit odd numbers can be made with 1, 2, 3, 4, 5? All right. Once again, you allow or do not allow repeat. So, whether a 3-digit number is an odd number or not an odd number depends solely on the last digit. Alright, this must be an odd digit if it is an odd number. Alright, so among the odd digits, this has 3 choices, this box. Alright, it must be chosen from 1, 3, or 5. Alright, however, for the other boxes, you are free to choose. You can choose 1, 2, 3, 4, 5, any number. So is the first box. Alright, because we want odd numbers. So we have the limitation on the last digit. It must be an odd digit. So altogether, we multiply them, the answer goes to 75. Alright, there are 75 odd 3-digit numbers made with 1, 2, 3, 4, 5 if you allow repeat. Alright. Now, on the other hand, if you do not allow repeat, what do we see? Alright. So once again, we consider the left-hand side, the digit on the right-hand side first. Right. Once again, it must be an odd digit, so it must be chosen from 1, 3, 5. All right. So there are 3 choices in the right-hand side box. All right. Now for the other 2 boxes, we are now down to 4 digits. All right. 1, 2, 3, 4, 5. One of them is taken. I don't know. Maybe it's a 5, maybe a 3, maybe a 1. But one of them is taken. So we are down to 4 digits. Alright, among the 4 digits, we choose 2 of them to line them up. So there are 4p2 ways to line up the other 2 boxes. So in the end, it is 4p2 times 3, and the answer goes to 36. Alright, we try to consider the most limiting case first. We consider the box on the right hand side first. Alright, think about how many choices are there in this box, and then once we settle this, we can go back and think about what are the choices for the remaining boxes. Alright, so these are the first question in 2 different varieties. Alright, let's look at the next page. Now, next up, it is almost the same question, only that I replace the 1, 2, 3, 4, 5 with 0, 1, 2, 3, 4. Alright, 0, 1, 2, 3, 4. I use the 0 to replace the 5. Now, what does that mean? That is a major requirement because a 3-digit number cannot start with 0. Alright, numbers like 4, 3, 0 is a 3-digit number, but numbers like 0, 4, 3 is not a 3-digit number. It is 43 only. Alright, it is only 2 digits. So that means that For 3-digit number, it cannot start with 0. All right. So once again, the same question. How many 3-digit numbers can be made with 0, 1, 2, 3, 4? All right. So once again, we using similar argument, set up 3 boxes and think about how many choices are there in each box. All right. We discovered that for the previously it was the one on the right hand side, right? But now it is the one on the left hand side. It cannot be 0, so it is down to 4 choices for the digit on the right hand side. All right, it cannot be 0, so there are only 4 choices for the digit on the left hand side. But then for the other 2 digits, you still have the 5 choices: 0, 1, 2, 3, 4. It can be 0, 1, 2, 3, 4. All right, you have 5 choices for the remaining 2 digits. So after all, the answer is the multiplication, and there are 100 3-digit numbers you can do. There are 100 3-digit numbers. All right, if you allow repeat. Okay, what if you do not allow repeat? All right, if you do not allow repeat, it's almost the same like the previous case, right? Only that we do not consider the digit on the right hand side first. We consider this one first. All right. So once again, there are 4 options. All right, 1, 2, 3, 4 for this digit. So there are 4 options, and then we have 4 digits remaining. We choose 2 of them. So there is another 4p2 arrangement. All right. So the answer is 4 times 4p2, and that goes to 48. There are 48 3-digit numbers you can make from 0, 1, 2, 3, 4 if you do not allow repeat. Okay. So try to contrast the question on the bottom, in the top half of this page, against the question at the bottom half of the previous page. They are very similar, only that in the previous question, the limiting case is on the right hand side, right? While in this question, the limiting case is on the left hand side. All right. Now, the highlight of this example is the last one. What if we combine the 2 together? All right, there are 2 limitations. First, it cannot start at 0. All right, it is a 3-digit number, so we cannot start at 0. And secondly, how many even numbers can be made? All right, for even numbers, the digit on the right hand side must be an even digit. All right, so let's think about this. Now, this is going to be more complicated than the previous 2. Once again, we start to consider what if you allow repeat. All right, it is easier if you allow repeat. All right, think about that. It cannot start at 0, so there are 4 choices for the leading digit. All right, on the digit on the left hand side, it can be 1, 2, 3, 4. So there are 4 options here. For the middle digit, there's no limitation, so there can be 5 choices here. And then for the last digit, it must be an even number. All right, so it is down to ending at 0, at 2, at 4. This will give you an even number. It ends at 0, at 2, at 4. So there are 3 options for the digit on the right hand side. All right, so you multiply all of them together, the answer goes to 60. All right, there are 60 even numbers, 3-digit even numbers you can make if you allow repeat, right? Because the green box, the green digit cannot be 0, so there are 4 options. The middle digit can be anything, doesn't matter. The digit on the right hand side, it can only be 0, 2, or 4, so there are only 3 options if you want even numbers. Now things get complicated if you do not allow repeat. If you do not allow repeat, all right? If you follow what we did previously, you will run into something you can't decide. For example, right? You start thinking about the digit on the far left, all right? So there are 4 options. It is 1, 2, 3, 4. All right. One of them is taken. It cannot be 0. But how about the even number? How many even numbers are there? Okay, it's 0, 2, 4. But wait, what if 2 is already taken? Then you do not have the 2. All right. But if 1 is taken, then you have 0, 2, 4. All right. So what I meant is the option for the blue box depends on what you took in the green box. All right, remember this. The available options on the blue box depends on what you took on the green box. If you took 1, 3 on the green box, all right, if you took a 1 here or 3 here, then there are 3 options for the blue box. However, if you took a 2 or 4 on the green box, then you are down to only 2 options in the blue box. All right, so you have to split into two cases. You have to split into two cases. Like case 1, alright, you start with 2 and 4. You start with 2 and 4. Or in the case 2, you start with 1 and 3. Nonetheless, it does not start at 0. Alright? It starts at 1 or 3. We consider the box on the left hand side first. Alright? Either it's a 2-4 or it is a 1-3. If it is a 2-4, then you are down to only two options here because one of them is already taken. I don't know which, but one of the 0 or the 4 is already taken. Alright? So you are down to only two options here. It's either 0 or a 2-4. Alright? So there are two options in the blue box, two options in the green box. Alright? However, if 1-3 is taken on the left hand side, you still have three options, 0, 2, 4 in the blue box. Alright? And then in the middle box, because two numbers they are already taken, so you have three options in the purple box nonetheless. Alright? So you multiply in each case. Alright, so this is 12, this is 18, and then you add them up. The final answer goes to 30. Alright? There are 30 three-digit numbers you can make. There are 30 three-digit even numbers you can make. Alright? But in order to arrive that answer, you have to split into two cases. Case 1, it starts at 2-4. Case 2, it starts at 1-3. Alright? Why do we have to do this splitting into cases? Because when I start with 2-4 or when I start with 1-3, there is an impact on the number of choices in the blue box. Alright? Now, alternatively, we can do it in another way. Right? There's an alternate solution to this question. We can consider the blue box first. Alright? And then we think about the green box second. Alright? We can consider the blue box first. And then we think about the green box second. Finally, we consider the purple box. Alright? But once again, if you do this, you still have to split into two cases. Alright? Case 1 or case 2. So, now it is 0. It is about 0, right? In case 1, it ends at 2-4. It is an even number, so it ends at 2 or 4. Alright? It may be a 2, maybe a 4. So there are two options in this box. Or it ends at 0. So there is only one option in this box. Now, why do I have to split into 2, 4, and 0? Because there is an impact in the green box. If you take away 2 and 0, originally you have 1, 2, 3, 4 options. Alright? But then one of them is already taken. One of them is already taken. You are down to 1, 3, 2, 4, either one of them. Alright? Because one of them is taken in the blue. So you are now down to 3 options in case 1. Do you get this? However, if 0 were taken in the blue box in the first stage, you still have 1, 2, 3, 4 to choose from. So you have 4 options in case 2. Alright. In case 1, because 2, 4 is taken in the blue box, so you are now down to 3 options. It's a 1, it's a 3, or either 2 or 4. Alright, so you have 3 options. However, in case 2, if 0 is taken as the on the right hand side, then you still have 1, 2, 3, 4 for the left hand side. And nonetheless, 2 digits they are chosen. So the middle digit, there are always 3 options to choose from. And let's see whether they arrive at the same answer. This one goes to 18 and this one goes to 12. If you add them up together, the answer is still 30. Alright, the same as the previous one. Alright, so we split into 2 cases because your choice in the one box has an impact on the second box. So we have to split into different cases so as to separate the effect. Alright. Now that does not happen if you allow repeat. It is much easier if you allow repeat because you can use the digit over and over again. Alright. So pay particular attention to this very last example and see, number 1, why do we have to split into cases? And number 2, why do we have to split into the cases into 2, 4 against 0? Or in the first example, into 2, 4 and 1, 3. Alright. So in the next video, we have even more examples on permutation and combination.